The universe as we experience it is a breathtaking tapestry of stars, galaxies, and life, a vast, intricate mechanism humming with purpose. We've always assumed this hum was the sound of ultimate stability, a cosmic engine running in its most perfect, lowest energy state. But what if that assumption is the grandest deception of all? What if our entire reality is nothing more than a temporary illusion, resting precariously on the edge of a cosmic cliff? This isn't some abstract philosophical musing. This is the false vacuum, the chilling possibility that our universe exists in a state that looks stable, that feels secure, but is in fact merely metastable. Think of it like a magnificent, perfectly balanced crystal sculpture gleaming in the light. It appears solid, unmovable, but beneath its base, unseen, lies a tiny, almost imperceptible bump on the polished table it rests upon. And just a few centimeters away, a deeper, more profound depression carved into the very wood. That's the true vacuum, the ultimate, lowest energy state, where the sculpture would truly be at rest, utterly stable. Our universe? It's the sculpture on the bump. We are in the false vacuum. For decades, physicists wrestled with the fundamental forces, building the intricate puzzle of the Standard Model. They thought they had mapped the terrain of reality, found the deepest valleys where everything settled. But then a new piece emerged, a cosmic titan that defied easy categorization, the Higgs field. This ubiquitous, invisible ocean permeates all of space, giving particles their mass, shaping the very substance of reality. It's the field that dictates how heavy an electron is, how much a quark weighs. It's the grand architect of atomic existence. But here's the terrifying twist: the cosmic betrayal. The precise measurements of the Higgs field, particularly its interaction with the heaviest known fundamental particle, the top quark, suggest something deeply unsettling. The Higgs field, the very foundation of our universe's stability, appears to be that tiny bump under the crystal sculpture. Its current energy state isn't the absolute lowest possible. It's merely locally stable, a temporary plateau in a much larger, steeper energy landscape. It's the prime suspect in our cosmic mystery, the architect of our precarious existence. It whispers to us, through the cold language of quantum numbers, that there's a deeper, more stable reality lurking just beyond our current state, a true vacuum that, if reached, would unleash an unstoppable wave of annihilation. The very field that gives us existence could, in an instant, erase it all. Now for the trigger, the silent assassin that could unleash this cosmic apocalypse. If our universe is a crystal sculpture, perched precariously on a bump, what's the tiny nudge that sends it tumbling into the abyss? The answer lies in the bizarre, counterintuitive realm of quantum tunneling. In the quantum world, particles don't always behave predictably. They can, against all classical odds, simply tunnel through energy barriers that should be insurmountable. Imagine a ball at the bottom of a shallow dip. Classically, it needs enough energy to roll over the hill to get to a deeper valley. But in the quantum realm, that ball can just blink through the hill, appearing on the other side as if the barrier never existed. This isn't some theoretical parlor trick. Quantum tunneling is real. It's how radioactive decay happens. It's how the sun ignites nuclear fusion in its core. And it's the terrifying mechanism by which our false vacuum could decay. All it takes is a single, solitary particle, perhaps even one of the Higgs bosons itself, to spontaneously tunnel, for no discernible reason, into that deeper, more stable, true vacuum state, one infinitesimal quantum blip. And that's when the bubble of true vacuum ignites. Think of it like a cosmic cancer, a perfectly spherical wavefront of annihilation that expands outward from that single point of decay at the absolute speed limit of the universe, the speed of light. This isn't an explosion. It's far more chilling. It's a phase transition, a fundamental reordering of reality itself. Imagine boiling water. When it hits 100 degrees Celsius, it doesn't explode. It changes phase. Steam forms. This bubble is like a superheated steam bubble, but instead of water turning to vapor, the very laws of physics are being rewritten inside. Within this expanding bubble, the Higgs field would settle into its true lowest energy state. And here's where the horror truly begins. This new lower energy state would fundamentally alter the constants of nature. The mass of elementary particles would change. Electrons, quarks, neutrinos, everything would have different properties. Atoms, as we know them, would cease to exist. The strong and weak nuclear forces, the very glue that holds nuclei together and governs radioactive decay, would be radically different. Chemistry, gone. Biology, impossible. Stars, they'd flicker out, unable to sustain fusion. Planets, they'd unravel, their constituent atoms no longer able to bond. This bubble, expanding at light speed, would be utterly unstoppable. There's no warning, no precursor, no cosmic tremor to detect. Light from outside the bubble couldn't reach us because the bubble is light speed. It's an instantaneous, absolute wipe. If such a bubble were to form even now, anywhere in the observable universe, we would never see it coming. One moment, our universe exists, vibrant and complex. The next, the bubble washes over us and everything, every star, every galaxy, every memory, every thought is utterly reconfigured into a new, alien reality where the laws of physics are fundamentally different and life as we know it is impossible. It would be as if our entire cosmic tapestry were unstitched thread by thread, not by some external force, but by a flaw woven into its very fabric from the beginning. It's a chilling thought, isn't it? The universe's ultimate vulnerability, hidden in plain sight. If you're finding this cosmic detective story as mind-bending as I am, smash that like button and subscribe to join me on our next deep dive into the universe's most guarded secrets. Now, how do we, the cosmic strategists, peer into this potential abyss? What forensic evidence do we have to suggest our universe is truly teetering on this knife edge? The clues, chillingly, come from the very particles that build our reality, specifically the precise measurements of the Higgs boson and the Mantown top quark. Think of them as the cosmic scales, whose delicate balance must hint at our precarious state. For decades, the Higgs boson was the holy grail of particle physics, the elusive God particle that gave everything mass. Its discovery at the Large Hadron Collider in 2012 was a triumph, completing the standard model. But the celebration quickly gave way to a new, unsettling realization. The Higgs boson's mass, measured with incredible precision, turned out to be around 125 gigaelectronvolts, GeV. This number, seemingly innocuous, is the first crucial piece of our forensic puzzle. Then there's the no top quark, the heaviest known fundamental particle. It's an absolute behemoth, weighing in at approximately 173 GeV, almost as heavy as an entire gold atom. Despite being a fundamental, indivisible particle, its immense mass means it interacts very strongly with the Higgs field. In fact, it's the top quark's interaction that largely determines the stability of the Higgs field itself. It's the anchor of the Higgs, but an anchor that might be pulling it towards instability. Here's where the cosmic detective work gets truly intricate. Particle physicists, armed with these precise mass measurements, perform what are called renormalization group equations. Imagine a complex multidimensional graph where one axis represents the energy scale of the universe and another represents the strength of the Higgs field's interaction. These equations allow us to extrapolate how the Higgs field's properties, including its stability, would behave at incredibly high energies, energies far beyond what even the LHC can reach, energies that existed only moments after the Big Bang. What these calculations reveal is profoundly disturbing. When you plug in the measured masses of the Higgs boson and the top quark, the equations point to a universe that is not truly stable, but merely metastable. It's like our crystal sculpture on that tiny bump. It's not at the absolute bottom of the valley. The calculations suggest that at an extremely high energy scales, the Higgs potential, which dictates the energy state of the universe, actually dips down again, forming that deeper true vacuum. This isn't a theory built on speculation. It's a direct consequence of the Standard Model, the most successful theory of particle physics we possess. Combined with incredibly precise experimental data, the numbers don't lie. They scream of a universe that is, by its very nature, on the brink. The probability of quantum tunneling into that true vacuum state is infinitesimally small, almost zero. But it's not zero. And in the vast, almost incomprehensible expanse of cosmic time and space, even an almost impossible event becomes inevitable given enough opportunities. So, the forensic evidence from our particle colliders from the very heart of matter tells a chilling tale. Our universe is not eternal, it is fragile. Its fundamental stability is an illusion, a temporary state dictated by the precise, almost too perfect balance of the Higgs and the top quark. We are living on borrowed time, unknowingly perched atop a cosmic time bomb, waiting for that single quantum trigger to unleash the unstoppable wave. It's the ultimate cosmic vulnerability, written in the very fabric of reality itself, detectable only by the most advanced instruments and the sharpest minds. This brings us to the most terrifying aspect of the false vacuum decay, the chilling, absolute lack of warning. It's the ultimate locked room mystery, where the victim vanishes without a trace and the perpetrator leaves no clues behind. Unlike other cosmic cataclysms, the demise by true vacuum bubble offers no escape, no heroic last stand, not even a final desperate scream into the void. Consider other cosmic threats, a rogue black hole. We could detect its gravitational signature, see stars being torn apart, and perhaps with unimaginable technology, even attempt to steer our civilization away. A gamma ray burst from a dying star, a terrifying flash, but light years away we might have a few minutes, hours, or even years of warning as the light travels across the cosmos. A galaxy-wide asteroid impact, centuries of lead time to devise a defense, a deflection, or a desperate evacuation plan. Even the slow, inevitable heat death of the universe allows for billions upon billions of years for consciousness to evolve, transcend, and perhaps even reshape reality itself. But the true vacuum bubble, it expands at the speed of light. That means it is, by definition, faster than any signal, any warning, any information we could ever receive. If a bubble were to nucleate in the Andromeda galaxy right now, we would never see it. The first we would know of it is when the leading edge of the bubble, traveling at the cosmic speed limit, washes over Earth. In that instant, our reality would fundamentally change. Our atoms would unravel, our very existence reconfigured by new, hostile physical laws. There would be no flash, no sound, no tremor. One moment, you are reading these words, contemplating cosmic annihilation. The next, your constituent particles are obeying an entirely different set of rules, utterly alien, utterly destructive to life as we know it. It's the ultimate cosmic ambush. We are trapped in a locked room, and the killer is already inside, invisible, waiting for an infinitesimal, quantum-triggered moment to manifest. The boundary of the bubble itself, AE, is light speed. So there is no before the bubble reaches us. There is only the now of its arrival and the after of our transformation. Even if we detected the precise values of the Higgs and top quark masses, even if we understood the equations perfectly, there is no countermeasure, no shield, no propulsion system, no theoretical physics that could allow us to outrun a wavefront traveling at light speed. It's an existential checkmate. This terrifying vulnerability has, of course, spawned desperate speculative theories among physicists, trying to find an alibi for our universe, a way out of this cosmic death sentence. Could there be some unknown, exotic particle, a dark Higgs perhaps, that subtly interacts with our Higgs field, stabilizing it in ways we don't yet understand? Perhaps our calculations are incomplete, missing some crucial piece of the quantum puzzle that would reveal a truly stable, ultimate vacuum, reassuringly deep and secure. Some even propose that the very act of observing and measuring the Higgs boson might somehow affect its stability, an anthropocentric paradox where our scientific curiosity plays a role in our own fate. Or, more esoterically, could there be other dimensions, other universes that somehow prop up our own, preventing its decay? These are desperate gambits, theoretical lifelines thrown into the cosmic abyss, hoping to grasp onto something, anything, that might prevent the inevitable. But for now, the cold, hard numbers derived from our most successful theories paint a bleak picture. Our universe exists in a fragile metastable state, a cosmic house of cards susceptible to collapse from a single quantum fluctuating particle. It's a silent, invisible threat, a fundamental flaw woven into the very fabric of reality itself, waiting for its moment to unleash absolute, unpreventable annihilation, the ultimate mystery without a detective and a crime without a witness. So, here we stand, at the precipice of a cosmic truth so profound, it redefines fragility itself. Our universe, this vast, intricate ballet of stars and galaxies, of life and consciousness, may not be the eternal, unshakable bedrock we once imagined. Instead, it could be a fleeting, quantum-poised moment, a magnificent, beautiful bubble of reality resting on a knife edge, waiting for the slightest tremor to shatter into an alien oblivion. The very fabric of our existence, the laws that govern every interaction, every thought, every breath, could be rewritten in an instant, without warning, without mercy, by a single, infinitesimal quantum whisper. It's a chilling prospect, the ultimate existential vulnerability. But perhaps within this terrifying realization lies a profound, almost defiant beauty. To exist at all, in a cosmos capable of such sudden, absolute transformation, is an astonishing gamble. Every moment becomes infinitely precious. Every discovery a fleeting glimpse of a reality that might not endure. This isn't just a scientific theory. It's a cosmic mirror, reflecting back the fleeting, precious nature of our own existence. It forces us to confront the ultimate unknown, to truly grasp the miracle that we are here at all, capable of contemplating such mind-bending possibilities. The universe, in its terrifying truth, dares us to find meaning in transience, to cherish the now, knowing that the next could be an entirely different reality. This is the kind of secret that keeps me up at night, staring at the stars, wondering if the next moment will be the last for everything we know. Tell me what you liked or disliked about this video. What do you think could be changed to make it better? I read every comment and will respond to every suggestion.